Excellent. 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 I am so excited. I'm going to give people a couple of seconds here. I guess we're actually already in a couple of seconds. That's really, I guess, the audio problems just serve as the giving people a couple minutes to jump into the chat. All right. I am so excited. Thank you for joining, everybody. Thank you for being here. My name is Elliot. If we haven't met before, I am a senior developer advocate and jack of all trades here at SDF. And what I wanted to go through today is talk about my own little project that I've made called KaleFail. And this is a very fun project that I've had a lot of fun with. And we'll get into some of the technical bits of it. But first, we need to kind of demonstrate, if you weren't here last week, 2 weeks ago, I'm not exactly sure, a little while ago, what kale is. And if you haven't heard of kale, you've been living under a rock for sure. It is this incredibly popular community. Just the community behind it is very active, very on fire, and very excited about this fun little mining token thing that our very own Tyler Vanderhoeven, also known as KaleFail, whose favorite food is kale, by the way. He created it. He dreamt it up, and everybody else has just kind of really latched onto it. And the essence of it is that it's, instead of mining like Bitcoin or Ethereum used to be, as a proof of work, like where one person hits the jackpot every now and then, or one mining pool rather, the whole thing is a giant community-driven effort. It's a proof of teamwork token rather than just proof of work. So everybody, including Matthias and Bree and Jerome and everybody in the community who's involved, is all like, as you are mining and you plant and work to do the mining things, everybody's contribution is sort of combined and collected all together. And that is what determines, partially, there's lots of fancy maths, that effort on behalf of the whole community is what kind of determines what your particular share might be when the time to harvest a block actually comes about. But kale is one thing. What I set out to do is create this thing that I like to call KaleFail. And it's sort of like, my mission in life is to be like the wish.com Tyler. And KaleFail is sort of like that embodied in a website. So like it's not like a fail as in I'm like it's broken things, or not like it's gonna rug pull anybody. It's just sort of a fail, like it's almost like the real thing, kind of like the real thing, somewhat related maybe to the real thing, but not technically the real kale. So the goal is to like create different projects, different contracts, different ways of kind of interacting with kale in unique, interesting ways. And we'll get into each of these different things a little bit more in depth. But first, just kind of general tour, we've got each of these: trading post, kitchen, tractor. Each of those represents a smart contract that I've written and has been deployed and interacts in one way or another with the kale contract, or the universe of KaleFail contracts, as it were. So what I've done today is I've been mining manually. I have not checked this automation box. And as you can tell, I am very, very consistent at getting things in on time. And I've actually not harvested a single thing all day long. And I did that for a reason. We're going to go through these KaleFail contracts kind of backwards. And the most recent one I released is this tractor. The tractor, it's it's very easy as you're mining. Things happen, right? Network latency mincy might show up out of the blue and you're not really expecting it. Or maybe your GPU miners like crash or something like that, and you don't really recognize it or realize it right away. And it's possible that if you have been not paying attention, these harvest blocks might pile up. Unharvested kale that you've worked really hard for. You have done the work or forgotten to do the work in my case, and your hard-earned kale is at risk of expiring. Like we talked about in the previous one, if you don't, these are all temporary ledger entries. So the storage by default lasts about 24 hours. And if you don't extend that or harvest these blocks in time, then it will just expire. It gets evicted from the ledger and your kale is gone forever, I'm sorry to say. So one of the things that I wanted to do very early on in this, but hadn't got around to it, is this sort of like tractor scoop up all of the kale that exists out there for a given user. Right, you don't want it to spoil. So that's what this one does. And my mining address is a CC4R blah, blah, blah. I'm going to copy it to my clipboard, and then I'm going to put it in here, and I'm going to fetch pails. And this site is actually doing this. We'll get into why this is done on the front end or on the server side rather than in the smart contract in a second. But it looks through the 200 previous kale blocks. A kale block like 36175, 36174, all these happens every 5 minutes or so, give or take. And there can, with the math, there's like 120 kale blocks per 24 hours. Coincidentally, the get ledger entries RPC endpoint, you can query up to 200 ledger entries. So this page searches for the 200 most recent kale blocks for your address. And if it finds any, and if it finds that you've actually worked during that time, and if it finds that it's a harvestable block, basically, it lists these out here, and then we can select them all or just a few of them, and then you click Harvest Kale. It doesn't ask for your username and your passkey or your secret key or anything. It just knows, because the Kale contract doesn't require authentication for a harvest call, then it can just fire off the invocation without really having to think twice. So like now I've harvested 2 of them, and if I refresh the page, my balance has gone up by 10. Sweet. Oh no, but see, this is part of the problem, right? Like I had a whole bunch more of these that have now disappeared, that if I were just using the web miner, they're inaccessible in a way. But this fetch pails thing still looks for all of those expired or missing possible harvestable pails that are in the ledger entry still. So I'm going to go ahead and harvest all of these, and fingers crossed, yes, I've successfully harvested 57 kale. That's excellent. That should put me over 900. Yes, I love it. It doesn't disappear from here because Tyler's site is doing some like session storage things, so it's not reflected here. You should have to click every single one. That's penance. I like it. So this contract, actually, let's switch to that if I can remember how to do it. Yes. Okay, so this contract is actually really simple. It's using a cross-contract call. So I have this contract client kind of built in here just so that I can pick out the harvest function without having to like import the whole WASM executable and all that. So since we're just using this harvest function, it's just a way of letting my contract know, the Kale tractor contract, know that this farm contract has a harvest function, and here are the arguments, and here's the return type. So this harvest function in my contract takes a farmer, which is an address type, and a vector of U32 pails. That's the Kale block number. And it keeps track of this total reward that you're going to get as it goes through each of these pails and tries to harvest. It gets the homestead contract. I think that's what Tyler has called it in some of the code. The homestead contract from storage, and we can safely unwrap it here without having to like check to see if it exists or anything, because we're using a constructor. Anytime this contract is deployed, it will have to run this function successfully. Otherwise, it won't be able to deploy. So you can safely just get and unwrap any storage entries that were set in this constructor function. So we're getting the farm address. We're creating a client out of it, this farm client that we defined up here. Where is it? Farm. And we're calling it farm client. And we're running harvest for each of the harvestable pails that we found. We're adding up the reward and returning it. We're also extending the instance TTL while we're at it, while we're here. So why are we accepting the pails in the function invocation instead of just like in the contract, let's do that querying for us so that we don't have to do that on the front end? The whole reason is because these contract storage is namespaced, so to speak, in a single smart contract. So my tractor smart contract doesn't have access to the ledger entries that the farm contract, the Kale contract, is creating and managing. Any ledger entries that I want to retrieve from the blockchain have to be retrieved either from the contract where it was written or from the RPC outside of a smart contract. It's sort of like a just separation of powers, so to speak. Yeah, you'd also like probably pretty severely trying to find 200 different ledger entries. You would definitely exceed the limitations and the budget. So we do that querying outside of the smart contract. In fact, I can show you. Let's see, source routes, made a little kitchen API. It's getting, oh, cool. Oh, that's because no, I don't have, it's going to give us TypeScript errors. Sorry, I don't know how to turn that off because it's just an empty, there's no svelte kit types. My bad. It gets the entry, the instance entry, so that it can query the farm contract. Kitchen? Oh, no, not kitchen. Tractor. I'm in the wrong one. Sorry. Double sorry, everybody. Okay, so we are getting the possible pails. We've taken an address as our parameter. It's right here. We get the Kale contract. I should probably make this an environment variable or something somewhere. Anyway, we find for 200, we search index minus and iterate, subtracting one each time. We get a ledger key that we will then pass to get ledger entries, so that this server endpoint is just looking for the current search index, which is really the current block minus one, because you can't harvest a block for the block that's still active, and then all the harvestable pails that are not like null or not falsy. So that's how we're getting those pails. And then it's a really simple matter of just sort of invoking this smart contract with the bindings like I love doing all the time. Okay, so that's our, is that our tractor smart contract? Yes. Any more since then? No. I don't know why there would be. I have in mind. Okay, let's see. Let's go back to this trading post then. This was the first kind of like KaleFail contract that I built. And the idea was there hadn't really been any like way to use Kale yet up to a certain point. Like people were accumulating it. It was awesome. It was a lot of fun, but there wasn't really a way to you couldn't really do anything with it. So I set out to create this sort of trading post, which imagine like a general store, right? And you're a customer and I am the owner and I have certain functions in this trading post that allow me to like add vegetables that are available, subtract, like take them away, like, oh, cabbage has gone out of season or whatever the case may be. I can expand or shrink the shelf space. 28.5 other veg. Oh, yeah. We can do a lot of different stuff with this contract, but as a user, you can really just trade kale for one of these vegetables, broccoli, cabbage, kohlrabi, or Brussels sprouts. You can do as much or as little. I'm going to trade 0.156. I want to keep a little bit of kale for, let's do cabbage. Make the trade, sign it with my passkey, and it'll think for a while. Coxie, I'm happy you're here. I love hanging out and I love just sort of yapping at y'all. We're making a trade and sweet. I have far less kale now and more cabbage. Everybody is happy. Everybody's excited. So this is essentially the reason that we did like 1-to-1 is because botanically speaking, the vegetable that is kale and broccoli and cabbage and Brussels sprouts, it's all like the same species or something. I don't know the right like biology terms for it, but all of that, they are like the same plant essentially that has just been selected for different attributes that people wanted. So I created this this trading post contract that manages these 4 different assets. So these are all issued assets by this issuer, and the smart contract, the trading post contract, is like the admin of it. If we go to like the smart contract for this, and we can look at the entries, the contract instance, the admin is this CBMG23VB contract. That's the address of our trading post. So this trading post is the one that is managing all of the minting operations or burning operations. And all the trading post does is it takes deposits of kale that somebody sends to it and then mints the broccoli or cabbage if they are trading in that direction, or it burns the broccoli, cabbage, the other vegetable, and gives back some of the kale to the user when they're trading in that direction. So the entire amount of broccoli, cabbage, kohlrabi, Brussels sprouts that have ever been minted is 144,957 plus that little bit that I just did. So these are always like the amount of broccoli, cabbage out there in the world will always be no more than the amount of kale held in this trading post contract. Always 1-to-1 redeemable. Yeah, let's take a look at some of this smart contract. This is a more complicated one, to be sure. Let's go source. Let's close this go back to Kale, contracts, trading post, source. So the customer, like this interface or this trait has three functions, just one really, trade. So we are checking to make sure it's open. We're requiring the authorization from the customer because we're going to spend their tokens. Essentially, we're going to transfer their Kale in one direction or another. So we're going to get all of our vegetables that are available from our storage. This is another function that just gets env storage instance get these vegetables. Again, this is built into a constructor, so I know that this is going to unwrap safely. And then since we're asking the customer which vegetable they want to trade for or trade against, we have to check that the vegetables that are available for trade actually contains the vegetable that they want to trade. Create a token client for Kale. Then depending on if they're buying the Kale, if the trading post is sending the Kale to them or vice versa, we create a vegetable client or a Stellar Asset client, because the burn function is part of the regular token client, but the mint function is part of the Stellar Asset client, like the admin side of things, if that makes sense. So depending on how they are trying to trade, we make the transfers, we burn if they're getting Kale out, we mint if they are putting Kale in, and that's what the user sees. We have in this contract, I've got my constructor function, I've got an upgrade function, add vegetables with logic built into that, and I'll add some links to this repository so that anybody can take a look and browse through it and see what mischief I might get up to. I'm just kidding, no mischief, guys, don't worry. Let's see here. What else is there? Oh, the airdrop that happened a little while ago. Tyler like 500x'd everybody's Kale balance, and I had everything like set and ready to go, and I had donated the Kale that was in the trading post so that after the airdrop, the trading post would have exactly the same amount that was in it before the airdrop. But at like the last minute, Tyler was like, you know what, let's do 501 times everybody's balance. I don't know why, but he did. So I had a small amount of Kale in the trading post that was unaccounted for. There was no vegetables that had been minted to get that Kale. So this burnt that extra Kale. I forget what it was. It was like 4.3 Kale worth. And that's all. Anyway, so this is the smart contract that is essentially the customer side of things is just trading. Like send me Kale and it will mint this vegetable. Otherwise, it'll burn the vegetable and send you back the Kale that you bought or traded for. Bought with Kale, I guess, before. Somebody did. Okay, let's take a look at this last part. And this is the most kind of exciting. Matthias doing the Lord's work there. So one of the things that I was excited about and took probably way longer to actually implement this than I should have or wanted to is this kitchen contract. And the way there are a lot of different ways that we could do this, but at the moment, this is just an NFT collection essentially that allows you to mint these NFTs, up to 5 of them. But each time you mint it, you're paying 1,000 Kale worth of the different trading post vegetables. So 250 broccoli, 250 cabbage, and on and on. So every one of these is generated to be unique from all the others. Like you won't have one that has the same colors in each of these quadrants and the same vegetables in the same order. So all of them are unique. All of them are one of one. And this is a strictly Soraban NFT contract. There's no issued asset that corresponds to these NFTs, whether that's good or bad. There's still discussion happening about Open Zeppelin has proposed an NFT SEP for like an ERC 721 like contract. This one is somewhat based on that. Some customizations I've done though as well. Perfect. Yes, that's it. Here, I've got a couple others too. I will get that here. I can copy that there, paste that. All of these are managed entirely in the contract storage. This page lets you look at your NFTs. You can even transfer, burn. This is a new feature I finally got working today. You can transfer, burn them if you want. I don't know why you would. That seems silly. But maybe you don't like that this cabbage is on green, and so you want to roll the dice and get a different one. You can burn it here or transfer it to a different account, I guess, and then mint a new one. Like it's limited to 5 per address, but you can transfer or like empty your balance, and then mint new ones if you wanted. So the smart contract, let's see here. We can look at some of the storage here. So we've got owners. This tracks the owner of each token, and this tracks the balance of each address. So right now, this one, I guess, is mine, 0, 1, 2, 5, and 18. All these are in persistent entries. The transfer from, like approval allowances, are stored in temporary storage. But yeah, this is all done in smart contract storage. Let me get that. Yes. Let's take a look at this contract. Kale salad. So what I've done here is I've got kale salad contract, and I've got this interface that I did, which sort of is the client side of what I was showing you earlier in the tractor. That's basically saying this non-fungible token interface has to have a balance function, and it has to look like this. Owner of function, and it has to look like this. On and on and on. So I've just outlined in this interface file module, crate, not sure the right word, what these functions should look like, and then all the programming and like logic is done in this directory, in this crate. So all of our non-fungible token interface functions like balance or owner of or approve, all that stuff is done in this implementation. Now, all of this is relatively straightforward. What I did have a hard time doing is getting this token URI function to work. So it should take a token ID that a user passes to it, and it should return like a URL that they can get access to the metadata for that image, for that token rather. So it checks to make sure that it's an actual valid token. Then it gets the metadata where the base URL is stored, URI, and then it turns the token ID into a string. Right now it's a U32, and I had the hardest time, let me show you this. I had the hardest time figuring out how to turn just the number into a string, because the U32, even though it's lower, it's going to be 250 or less. That's the limit of the NFTs. getting it into a string is not trivial in Rust, or at least in Sorbonne's version of Rust. So I have to parse out the number of digits and figure out how to like slice the array of values and bits and bytes, and it was far more complicated than I expected it to be, but I finally got it working. This was also broken until today, I realized. But yeah, all the like regular kind of stuff, the symbol, the name, all that is done in this non-fungible token interface implementation block. We've got transfer from and approve all, those kinds of things. And then the like custom logic, the constructor is this one. Yeah. Constructor, which requires auth, sets some admin things, sets which vegetables are required for payment, how much the payment is for each NFT, saves the metadata stuff, sets the supply and mint index to 0 so that we can start. And then there's an upgrade function, set price function if I decide, if the community is like, you know what, we're not going to pay 1,000 Kale for your stupid JPEGs, Elliot. That's all right. I can adjust this price if I need to. This mint salad function is kind of where everybody gets their token. And the number of tokens is, you can specify up to 5 here, and it checks to make sure that you aren't trying to like mint more. Like if you've already got 3, you can't mint more than 2 NFTs. And so it does some logic, and it takes, for each of the vegetables, it burns the 250 250 balance of those vegetables, and it gives you back, it mints and adds to your balance, which I'm storing as a vector. Not like ideal, probably, if you were going to like, if I'm artificially limiting, like there's no real need to limit everybody to 5 tokens or fewer. But if it were possible to hold a lot of these NFTs, that balance vector might grow to an unmanageable amount. And so this, that would probably be a different way you would want to do those storage entries. Let's see. What else are we doing? Then we're setting the supply to include the number of tokens that were just minted. We're setting the mint index to the new mint index so that we know where to start minting from here for the next invocation. And we're adding your tokens to, we're storing your newly updated owner balance vector. Let's see. Other things like the decimals, which is always going to be 0 because they're non-fungible tokens, but that's a useful, I think, thing to include, because most like cap 46 6 tokens or SEP 41 tokens have this decimals thing included. So it's very cheap, and you don't even have to put this transaction on chain. If you want to invoke the decimals function, it just returns 0. There's burning functionality, burn from if you're doing like an allowance or have like this NFT auction contract that's managing things. But yeah, that's kind of the broad overview of this NFT contract. Certainly not the first like ERC 721 like contract that I've seen around, but I haven't seen many. And OpenZeppelin is currently working on their SEP. So if you are interested, head over to the Stellar Protocol repository and you can chime in on the discussion around that SEP. But that is KaleFail in a nutshell. I feel like I yapped for hours. It's been like 40 minutes, I guess. That's not too bad. Okay. Any questions or anything that y'all have? Customize your NFT by using Kale to change features. Ooh. Like, so I might. Interesting. How do you have in mind, Matthias? Like, yes, there is tomorrow a meeting with Open Zeppelin. I want to say it's like 8:30 California time tomorrow morning, since a lot of the Open Zeppelin team is in Europe, works for their time zone. When minting, pay more to change the background color for your NFT. Ah, interesting. That's a very interesting idea. I would love to do something like that, and I might try to do like another round of NFTs. As it is, all of these like JPEG images have been minted already, or not minted, created, generated rather. Um, and here, in fact, is the script I made to use it to generate them. So they're all uploaded to IPFS already. It's just sort of like tracking that ownership of this particular token. Number 4 is now attributed to CCPFV6DZ or whatever the relevant address is. But that was one of the things I was interested in trying out. Like, how can a user, like, maybe they pay more, pay a little like fee of Kale or something like that to request like a specific token. Like right now it's just sequential, right? Like we have 27 minted. The next one minted will be number 20, I guess 7 because it's 0 indexed. Maybe they want to get like number 100. Maybe pay like a little extra fee or something like that, or even just request it. I'm not all about like draining everybody for fees or Kale or anything. Gold colored cabbage, that'd be pretty sweet. Another, like, I was going back and forth with this salad thing emoji in the middle. My daughter helped me figure out if we should put it in there or not. But I thought about like tilting it to make it just that like much more different on each one. I didn't, as you can tell. Or rotating these, but that kind of looked funny. Yeah, maybe this does become like a sort of, what do they call it? Like a launch pad for your own NFT projects or something. Slightly rotated salad. Sweet. All right. If there's no other questions, I guess I can. What? I'm not sure I know what OST means. OST? Original. Oh, I am far from a musician and I'm far from good enough at AI to try and become a musician, I'm afraid. All right, everybody, I have had a really great time. Always great to see you all, your wonderful faces. I'll have this recording and the other one that I still have to chop up and upload available very soon. It's been amazing hanging out with you all. Thank you for showing up and listening to me blather on about my little pet projects. Have a great day, everybody, and I will go get my kids from school in a minute. Have a great one, everybody.